This is the Geometry Chapter 2 Final Review. We had a variety of objectives this chapter, but the kind of overarching theme of this chapter was proofs and logic and reasoning. And so that's what we're going to kind of talk about. We talked about using inductive reasoning to make conjectures, recognizing conditional statements and their parts. Those are your if-then statements, your hypothesis and conclusion. We wrote converses, inverses, and counterpositives. We wrote biconditionals, and we use those to help us recognize when we have a good definition. We used these law of detachment and the law of syllogism. We connected reasoning and algebra and geometry, so we did those algebraic proofs. And then eventually we proved and applied theorems about angles. So we're just going to kind of start off talking a little bit about these conditional statements, recognizing the conditional statements and their parts, and then being able to write some eventually. So it says identify the conditional statements below. So there are 4 statements here about a rhombus and a rectangle, and actually only 2 of them are actually conditional statements. So why don't you pause the video here and see if you can identify which 2 are conditional. All right, what you should have identified was the second statement and the third statement. The reason being, the second statement has if, then, your basic conditional statement. The third statement actually kind of changes up a little bit. If doesn't happen until halfway through, but that's okay. They can do that. That just means they reverse the order of their hypothesis in the conclusion. A polygon is a square if it is a rhombus and a rectangle. We can rephrase that and say, if a polygon is a rhombus and a rectangle, then it's a square, which is exactly what they set up above. So both of these 2 are going to be your conditional statements. So conditional statements have these parts, hypothesis and conclusion, and so what we are going to do is identify them in the statements below. Hypothesis we refer to as P and conclusion as Q. Why we picked those 2 letters, I don't know. But it says if you have a calculator, then you won't have to borrow one from Mrs. Gosha. So the hypothesis is what started off with, okay? It's the, if you meet this, then the second thing happens. So that kind of leads you on to the if, then. So the hypothesis is this part that you have a calculator. The conclusion then is the part that comes after then. It says you won't have to borrow one from Mrs. Gosha. Okay. So we've got another statement like this down below, another conditional statement. What you need to do is go through and identify the hypothesis and conclusion on your own. So I'm going to pause the video. I want you guys to read through this statement about the Walking Dead and see if you can identify the hypothesis and the conclusion. So this one was a trick statement because if happens halfway through the sentence. So the hypothesis then is that part that comes after the if, you watch The Walking Dead, and the conclusion then is you know who Rick Grimes is. Okay? Moving on, after that we talked about these things called converses, inverses, and counterpositives of conditionals. So this is when we change the order or we negate things. So we have this sentence, if you have your license then you can drive a car. What we are going to do is find out what the converse, inverse, and the counterpositive of this statement below is. So first off, you want to identify the hypothesis and the conclusion. Your P implies Q. That's your conditional statement format. That's what you start with usually. So if you have your license and you drive a car, well, hypothesis is, hey, you have your license. The conclusion is, hey, you can drive a car. What the converse does, if you don't remember, it actually takes that order and it flips them. Q implies P. So that's what we're going to do. We're going to say, if, we start with that if, you can drive a car, then you have the hypothesis, you have your license. Okay, so it just takes the order and switches it. The inverse and counterpositive both do the same, similar things, not quite the same. But these result in negating occurring. So what happens with the inverse is we're saying, hey, well, the hypothesis isn't true, then the conclusion isn't true. So we keep that original format, but we say the opposite of them. So you have your license. The opposite of having your license is not having your license. So we say if you don't have your license. And we negate the second half as well. So the opposite of you can drive a car is you can't drive a car. So converse switches the order. Inverse negates the original. Contrapositive does everything. It switches and negates. So it's going to take that QP and not P not Q and combine it all together. So it's going to go not hypothesis means not conclusion. So we start with the opposite of the conclusion. You can drive a car. Opposite of it is you can't drive a car. So we say if you can't drive a car, then you don't have your license. Now what we haven't talked about is the true-false values of these. Not all these have to be true. The first sentence, if you have your license, then you can drive a car. Well, the state of Minnesota, you have a driving license, you can drive. That is true. If they all of a sudden decide you can't drive, they'll take that license away and now you don't have one. But the opposite, if you can drive a car, then you have your license, that one isn't necessarily true, because if they, you might know how to drive a car, but you might have had your license taken away. So that's not true. Or maybe you got taught how to drive early because you live out of town and maybe your parents taught you how to drive the four-wheeler around or something. You can drive, but you don't have your license yet. The next one, if you don't have your license, then you can't drive a car. Like we just talked about, that's not necessarily true. Legally, you can't drive a car, but that doesn't. But we didn't say anything about legality in here, so that one would actually be false as well. And the contrapositive, if you can't drive a car, then you don't have your license. That's actually going to be true. If you can't drive a car, you don't know how, which means you never took the classes, which means you don't have a license. The interesting thing about this that happens is if the conditional, this first statement appears true, the one that was typed out, then the contrapositive will also be true. They have the same value. And the converse and the inverse always have that same true or false value as well. So, what I want you guys to do is pause the video and try the same thing down here. Try to write your own converse, inverse, contrapositive, and then think about the true and false values of all of these. The statement is if it gets too cold, then we will have a snow day. Okay, you can check all your statements with mine. The converse is if we have a snow day, then it's too cold. Inverse is if it's not too cold, then we don't have a snow day. And the contrapositive is if we don't have a snow day, then it is not too cold. If we think about the true and false values up there, for the first one, if it gets too cold, then we have a snow day. That is true. That happens. Converse, if we have a snow day, then it's too cold. Well, that is actually false. We'll talk about that in a second. If the converse is false, it also implies that the inverse is false. If it's not too cold, then we don't have a snow day. And the contrapositive has to be true because it has the same value as a conditional. If we don't have a snow day, then it's not too cold. Reasons for why the converse and the inverse are false would be you can have a snow day for too much snow and then it's not too cold. It's just there's too much snow. So that would actually be your counterexample that would prove the converse and the inverse false in this case. Okay, so after this, we started getting into our algebraic proofs. So we talked about all the different properties. So it says learning objective is that students will be able to connect reasoning in algebra and geometry. And it says identify the property being used. We're looking at the property that goes from the left side of the equation to why the right side of the equation is true, or why the if implies the then in these statements. So why don't you pause the video and fill in as many of these as you can with the algebraic property. Okay, if I look at the first one, it says 2 times the quantity x plus y equals 2x plus 2y. You just distributed the 2 through. That's your distributive property. Move on to the next one. It says if x equals 3 and 3 equals y, then x equals y. That's your linking property. So typically we would refer to that as your transitive property. That links two statements together to make a third. It says AB is congruent to AB. The order didn't change at all, so that's actually going to be your reflexive property. Move on to the next one. If 2x plus 2 equals 8, then 2x equals 6. We look at what changed. It went from 2x plus 2 to 2x, so they subtracted 2 from both sides. So that's your subtraction property. If you subtract one thing from the same thing from both sides, your equation is still true. The next one, if 5x equals 15, then x equals 3. We look at the change. Well, it went from a 5x to an x, so I think about to do that, I would have to divide by 5. Divide 15 by 5, and you get 3. That's your division property then. And last but not least, it says x plus 3y equals 3y plus x. Remember, they change spots. So it's like when you when you start at home and you go to school, and at the end of the day you go from school to home, you're commuting. That's your commutative property. If you want to spell that all the way out, here you go, commutative property. All right, and so what we are going to do is now we're going to write an algebraic proof, and we're going to use some of these properties here. So it says, given that 2 times 2x plus 5 equals 5x minus 20, prove that x equals 30. So remember, to start a proof, we usually like to write our first statement as a repeat of the given. We go 2 times 2x plus 5 equals 5x minus 20. And our reason is that we were given this. And now from here, we're just going to start solving this like we would a normal equation. If I look at this, the next step I might do is I get rid of this 2 out in front. So I would take that and I would put it through those parentheses. That gets me 4x plus 10 equals 5x minus 20. Well, that is, you want to think about what do you call that when you take that 2 and put it through the parentheses. That's the first thing we did up above. That's our distributive property. Okay, and now I look at what I have. I have 4x plus 10 equals 5x minus 20. Well, typically I would try to get all the x's together, all these variables together. So that's what I'm going to do. I'm going to bring the 4x over to the 5x. And I get 10 equals, well, that's x minus 20. You want to think about, well, what did I just do to both sides of the equation? I subtracted something. Well, that's just your subtraction property of equality. You can do that as long as it's the same thing for both sides. I look at what I have next. I have 10 equals x minus 20. Well, I need to get rid of that negative 20. I'm going to add 20 to both sides then. 20. And I get 30 equals x. What did I just do? I added. That's my addition property. Now, some of you guys might stop. Technically, we do actually have one more step, because when they say prove x equals 30, we want it to technically be in the same order. So we would actually flip this around to say x equals 30, and that would be your, that would be the symmetric property that allows you to change the order. Some people like to think we'll put down reflexive property. Technically, it's a symmetric property that lets you alter the order of the equation. Okay, so those are kind of your basic algebraic proof. From there, we then moved on to talk about proving and applying theorems about angles. So, oops, skipped ahead too far. Here we go. We're going to actually prove that the vertical angles theorem is true. It says, given that angle 1 and 3 are vertical angles, prove angle 1 is congruent to angle 3. Now, this one can be a little bit long, so you might want to write kind of small. We started off the same way. First reason, our first statement is angle 1 and angle 3 are vertical angles. Our reason is given. Now, my advice is always to look at the picture. If you look at the picture, there's another angle, 2. So somehow we probably want to relate angle 1 to 2 and angle 3 to 2, and then maybe use that to help relate 1 and 3 together. So if you think about it, this angle 1 and 2, well, I notice they're next to each other and they make a straight line. And this angle 2 and 3, they're next to each other and they make a straight line. That's your definition of a linear pair. It's kind of a big deal. So I would probably say that. Angle 1 and angle 2 are a linear pair. Angle 2 and angle 3 are a linear pair. And the reason for that is just your definition of a linear pair. Two angles that are next to each other make a straight line. Why we would do that is because there's something called the linear pair postulate, and that's a big deal. The linear pair postulate says, hey, if they make a linear pair, that means they're next to each other, make a straight line. They're supplementary, they add up to 180. So that's where I can go next. Oh, the measure of angle 1 plus the measure of angle 2 is 180. The measure of angle 2 plus the measure of angle 3 is 180. And that's called your linear pair postulate, the LPP. That's a pretty useful one. Remember that one. Now, if you notice, we're doing two things at once. It's because we can do two statements in one because they have the same exact reasoning. But what we can do now is actually take these two equations in the step 3, and since they both equal 180, they have to be the same. So I can actually take these two and I can combine them into one equation and say, hey, these two things are equal because they both add up to 180. Think about what's the reasoning behind that. That's your substitution property. You could make an argument for the transitive property here as well. Now, if you look at that, we're trying to say that 1 and 3 are congruent. Well, if 1 and 3 are congruent, that means they're also equal. So if we look at this on this equation, on one side I have angle 1, and on the other side I have angle 3. If I can get those to just say angle 1 and angle 3 without these angle 2's, then I'd be good. Well, I'm adding the measure of angle 2 on both sides, so what if all of a sudden I decide to subtract it? Well, then the measure of angle 1 equals the measure of angle 3, because these angle 2's cancel out. We have to think about, well, what's the reasoning behind that? What did I just do? I subtracted. That's my subtraction property. Now, we talked about, well, if two things are equal, they're also what? Congruent. So I can say, well, if these two things are equal, they're the same. That's what it means to be congruent. Angle 1 is then congruent to angle 3. We have to think about, well, what's the reason behind that? See if you can fill that one in. That's just your definition of congruence. That's what it means to be congruent, is that two things are the same. Okay, so an interesting proof, it used this linear pair postulate. Everybody forgets that one. Don't forget that one. Use the definition of congruence. A lot of people forget that reasoning as well. They're two pretty big ones. All this next one actually asks you to do is find the missing angle measures. So pause the video real fast here and try to find missing angle 1, 2, and 3 measures. All right, we should have gotten angle 1 to be 59, 2 to be 121, and 3 to be 59. If you want to talk about the reasoning behind this, I would see that 2 is vertical angles with 121, so I knew they were the same. And then I saw a lot of straight lines, so I went, oh, angle 1 and the 121 degrees are supplementary. 180 minus 121 got me at 59. 1 is then vertical with 3, so 3 is also 59. This next one, it says the two angles below are supplementary. Find the missing angle measure. Pause the video, try this one on your own first, and then let's talk. And you should end up with the missing angle measure being 45 degrees. So this was the end of the chapter 2 preparation for the final. Good luck.